have to fabricate separate components at high frequency. That is going to be the passive IC components. We are going to study about fabrication of resistance, inductance, and capacitance at high frequency circuits. Then some of the common impedance matching networks we are going to study, which will deliver maximum power from source to your load, and the different amplifiers which are available in practice for the applications: common gate, common source amplifiers. See, we are not studying about BJT. We are going to completely study about MOS only, because BJT has become obsolete. BJT is used only for laboratories nowadays, and everywhere MOS has completely replaced your BJTs. So we are going to study about the amplifiers which will be based on MOSFET, and some amplifier properties. We have rise time, what is the bandwidth, what is the gain, how to enhance the bandwidth. All these things we'll be studying. And for high frequencies, what all considerations we have to apply before designing the MOS amplifier, the high frequency amplifier design. And then we move to low noise amplifiers, different types and the different configuration of low noise amplifiers. Two types of amplifiers are available in the market. One is called as LNA. LNA means low noise amplifier. The other amplifier is called as HPA, high power amplifier. See, when you want to send signal over long distance, we will be using HPA. Or I'll put it this way, all the transmitters use HPA because a signal with a very high power can travel long distances, and that signal will be reaching your receiver. That signal will be corrupted by noise. So I have to discard the noise and I have to extract only my signal. So at the receiving end, I'll be using low noise amplifiers. So these low noise amplifiers are very intelligent. They will discard all the noise. They will amplify only your signal and give it to the receiver for processing. So we are going to study about low noise amplifiers as a part of this unit. And high power amplifiers will be studying in the next unit. Also, HPAs will be studying in the next unit. The next unit is about feedback systems and power amplifiers. So as you can see, power amplifiers, you have class A, class B, class A, B, C, D, E, F. All the different types of class A amplifiers we have, we are going to design them using MOSFET and see what are the parameters and the stability of these amplifiers. So how to ensure that my amplifier is stay working perfectly at high frequency, operating at a very high power. The high power amplifier, the power level is very high in the order of watts. So when the power level is very high, there is a chance that the system may go to the state of instability. So in that case, I have to use some techniques to ensure that my system is going to be always stable when it is going to work at high power levels. Okay. So this is all about unit 3, and unit 4 is going to be the typical components of an RF system. So you will have all these components: RF filter, RF oscillator, and RF mixer in any wireless communication circuit. So any circuit you take, without these components, your RF link will not be established. So we are going to study each of them, the different configurations available, the different types of oscillators, mixers, RF filters, how they are applied to real-time circuits. All those things we are going to study in Unit 4. Unit 4 is going to be specifically oriented only for these three components: filters, oscillators, and mixers. Filters are going to allow only one particular range of frequency, and it is going to block the remaining range of frequencies. So different types of filters, low pass, high pass, band stop. So all these filters are going to be RF filters. Oscillator, any circuit which generates oscillations without any AC input, it is going to be oscillators. And mixers, so when I am transmitting a signal, I always prefer transmitting a signal at high frequency, because the losses are going to be minimal, that the signal can have larger power and it can travel for longer distance. So what circuit can change my frequency from low frequency to high frequency without changing the content? That is going to be mixer. So the mixer is a circuit which translates frequency. Translating means I am changing the frequency from low frequency to high frequency, but I am not changing the information content in my signal.